I've had a few messages about the Blackout Buddy, which is a water-powered LED flashlight, and Daniel Burchell went one step further and sent one to me. I didn't realise these were even available from Amazon. That's where he sent it from. So thanks, Daniel, and let's take this to bits. But first of all, I'm going to take a guess at what's inside, and we're going to do an experiment and find out how it works. Because a common misconception with these is that they're entirely powered by water, and that would be great. I mean, if you had a battery that you just added some water in and then it just burned up the water and created electricity and, you know, just ran forever on water, that would be great. But that's not actually what's happening here. It's most likely using, and I can see a sort of stripy pattern inside that alludes to this, it's probably using a voltaic pile, a basic sort of battery. Now, if I get a notepad here, if you get a piece of metal, say for instance zinc, and in these experiments I'm going to be using some zinc plated steel washers, so that's zinc, and then you put an electrolyte separator, which in this case is going to be a bit of cardboard impregnated with acid, and by acid it's not anything dramatic, it's going to be vinegar, strong vinegar, and then you put on another disc with a different metal, copper in this instance. All metals have a different, is it an electron voltage they call it? It's a different potential. And when you actually apply, if you were to just dip to, well, look what's happened here. Here's the vinegar. And just out of interest, I stuck, this is the original, this is the zinc washer, but it's now completely copper plated because I actually deliberately put it in with the copper coin. And by putting them physically in contact with each other, touching in the electrolyte, actually I should have thought of paper towels, not to worry, here's paper towel. It's actually had an electrolytic action where it's created that voltage and then the copper is transferred onto the zinc. But what we're actually going to be doing here is, if I was to, say for instance, get this zinc washer and this copper coin, and well, actually, you know what? I should soak this this bit of cardboard. This bit of cardboard, which is actually part of the packaging from Amazon, coincidentally. So if I soak this bit of cardboard in here, so it's thoroughly soaked in the vinegar, and then I place it between the two layers of metal, and then I get a meter. Very strong vinegar, I should add. I set to 2 volts. And I place the meter across this, then if the vinegar is soaked right through, I should be getting a voltage. I am getting a voltage. I'm getting about almost a volt from the zinc and copper differential. And the current, I should also be getting a modest amount of current. Let's, without getting vinegar all over the meter, although it is a waterproof meter, which is quite nice. Actually, no, this meter is not rated waterproof, I don't think. It's similar to the one that is. So let's put this down to DC current. Oh, let's try something better than the 20 amp range. Okay, so I'm getting at the moment, I'm getting about 3 milliamps, and it's a dead short, so because of the way these things operate, the current will drop quite quickly because it is a dead short, but it's a few milliamps at about a volt. So if I want to actually extend on that, if I want to go create enough to light an LED, I'm going to have to stack more of these together. So I'm just going to take this out of its amps range and stick it back to the volt-ohm range. If I then take a number of these, so here's a zinc, spacer, copper, and then I put another of these arrangements. So I put the zinc directly on the copper, so they're just physically touching. It's like connecting batteries in series. Zinc. There's the electrolyte separator and copper, and I just keep building them up like that. Then theoretically I should be able to just stick an LED across them and it should light. And what they've actually done here, it looks like they've made that pile, but it's dry. They've probably got the chemical in there that is going to reconstitute into electrolyte when the water's added. But because they've kept it dry, it means that it's a battery with virtually an infinite life. I mean, the chemicals could break down, but it's not like a battery that's just going to gradually, because there's always some slight current flowing in a battery, even though it's very, very minute. A liquid battery, like a AA cell, something like, something like this, would gradually deplete over time. So let's build that arrangement up. and we'll make it dry to emulate this, and then we'll be taking this apart afterwards though. So we start off with a zinc electrode at the back of this, and we stick copper on top. And then we make the next cell. I've got the separator between, but it is dry at the moment. So then we get the next cell is the zinc, the separator, copper, zinc, separator, copper, zinc, separator, copper. I'd like to say that I've not actually tried this yet. So this may not work. The zinc will be the negative. Let's see what way around this. Put this LED across like this. And I'm going to clamp it all in place with this clamp just to hold everything together and sort of try and line it up to the middle. So at the moment the LED is not lighting because there's no electrolytic action taking place here. And I'm going to now dip this in here and the acid should start going up. Is this going to work? So it should start wicking up into the cell to create the battery. And absolutely nothing is happening. Well, that's a good start. Oh, why is it not working? Or is it just because the acid isn't really soaking in? It's soaking all down my hand at the moment. No, I'm not getting a Scooby here. If I put that LED on the wrong way around, that would be... Oh, I've just dipped the whole thing in. Oh, there it goes. It just wasn't penetrating in properly. And now it's gone out again. And now it's glowing and it's dimming up and down. Oh, come on, work. Okay, it's not super bright, but it's a start. Can I encourage this to go any brighter? No, it's actually, I think it was shorting out through the actual, because I was suspending the cardboard into the water, it was actually shorting out through that. Okay, so you get the gist. It's now lit, it's glowing, it's not super bright, but then this isn't really optimized. It's not probably a great electrolyte. It's actually getting a bit brighter, is it not? It's proving a point. Okay, right, having screwed that bit of the video up, I wonder how long that's going to stay lit now. So I'll sit it down there and it can just stay glowing in the corner. So this will be more heavily optimized, this device. So let's take this apart now. I wonder how long that's going to glow for. Ultimately, I suppose it will just be until it dries out. And will it leave enough acid soaked into the separators that if I just added some water afterwards, it would reconstitute it? I'm not really sure. Anyway, opening this up now. I could add water to this, we could see it actually go, or I could start taking it to bits. It's got a label over here to actually stop humidity going in, because if the electrolyte absorbed moisture. Now, do I want to open this up or do I want to activate it first? I think we want to activate it first, don't we? Oop, it's got a little cap comes off here. Or is that going to reveal anything? Is it going to let me pull anything out here, or am I just going to break it? Probably just going to break it, haven't I? I don't know if that... Where's the spudger? There's a spudger. I don't know if that's just a sort of moulded lip, or if that's actually a bit that will... That's actually physically... Maybe the whole lot's fed from this end of the battery to the other end. I don't think so. Is it going to split in half? Let's try breaking it. That's still glowing. Ooh. Right, tell you what, let's add some water first, because that would be quite a good thing to do. So they say you can either dunk it in the water or just add a few drips in the end. Let's try pouring some drips in. And keep in mind, this battery technology in here, this water-based battery, will be heavily optimised. You know, it's not new, it's been around for a while. And you know, they are lit. I wouldn't say it's mega bright. I get the feeling this is mainly intended as a novelty. It's getting brighter though. Okay, so now we've seen it that it actually works. Let's see if we can actually get this open. I may have to squeeze this in the vise of knowledge. Where is the vise of knowledge? I can't see the vise of knowledge under here. What have I done with the vise of knowledge? Oh, where is it? I'm not doing very... Oh, here it is, isn't it? On the ground. I've obviously been using it for violence earlier on. So let's squeeze this and see if we can actually break into the case in some way. Oh, this is well sealed together, I have to say. I may have to pause for extreme destruction. I might even have to Dremel this open. I have a horrible feeling right now I'm going to have to Dremel this because it seems to be so well sealed together. It looks like it has been ultrasonically welded together perhaps down the case, unless that's just a manufacturing seam. Rightio, I can actually see, looking down, I can see the silvery metal and coppery metal, so there is a possibility this is something very similar to this, but obviously just somewhat better than mine. So I'm just going to pause momentarily while I open this. Okay, it turned out to be easier than expected because it doesn't even have... I thought the LEDs were mounted in a circuit board, and they've got that air seal at the back, but nothing at the front. So technically speaking, moisture can actually get through the front of this because all it seems to be is these plates just all stacked together in here. And as I squeeze this, I'm pretty sure I can see a slight variation in brightness. So let's take this apart. This is copper. I wonder what the electrolyte they're using is. So the LED leads are just literally clamped right across here. This is probably, I'd guess, magnesium? Not sure, or is it aluminium? The LEDs are just physically taped across it. And we have... You know, this is just a voltaic pile, as I've created there, but obviously this one is definitely more effective. Oh, this looks like it could be carbon. This could effectively be a zinc carbon. So yeah, there's the electrolytic separator there. There's a fibre with what looks like carbon in it. Then it's got the zinc and then a layer of copper making connection. I think this is effectively a zinc carbon cell. So how many sections has it got? It's got there's one layer of carbon, 2, 3. It's got 4 cells effectively in it. And what voltage is each one? Let's measure them. Wondering what the electrolyte is. I wonder if it's caustic to fingers. I'll find out later on when they start stinging. So let's set this to volts. The generation of a voltage between differing metals in an electrolyte is something that's particularly important in boats, because if you actually, let's get this down to 1 cell, if you have a boat with dissimilar metals in the vicinity, oh, that's quite high. That is actually quite high. This is effectively a zinc carbon cell. So that's a stack of zinc carbon cells. And the reason mine's not very bright is ultimately because it's not got many cells. Is it still glowing? Yes, it is still glowing. I reckon it was just on the borderline of actually driving that LED then. The temptation is to actually make that a bigger stack and see what happens, but I'm not so sure. So that's quite interesting. It basically is, it's a dry zinc carbon battery with some sort of dry electrolyte in here that once it's made wet, then there is something to make that conductive, because water alone would not be conductive enough. So there must be something in this layer that is maybe some caustic material. Does it make my fingers feel? No, it doesn't really. It could be a salt, it could be... Doesn't taste too caustic. I shouldn't really be tasting things like this. I'm just going to go and spit that out. One moment. Yeah, if anything, there's certainly not an acidic content to that. It was more a slight saltiness. So it's just a sort of salt, you know, some chemical salt that's in there between these plates. And that's fundamentally it. The Blackout Buddy is a stack of 4 zinc carbon cells in flat plate form, forming a battery that is dry and will last for ages. But as soon as you add the water to it, then things will, you know, the metals that it's made of will start corroding. The zinc will start transferring to the carbon, I think it is the direction it goes, which is the positive side and which is the negative side. We can measure that. Oops. Yeah, we can do that. We can measure it across this and see which side's positive. I'm guessing the copper is the positive. The copper side, so that copper is on the carbon, so the carbon will probably be transferring over to the zinc, but the zinc would probably corrode away in the process, I think. Or would the carbon, I'm not sure how that goes. I'm guessing they probably use carbon as opposed to another metal because, well, what would happen if I removed the carbon completely and just stuck the copper directly on there? I still get a modest voltage, but I wonder what effect, you know, I wonder what characteristic the carbon adds to the cell. I mean, they obviously use zinc carbon cells, so the carbon must have a sort of important function there. But it's quite odd because this looks like it's impregnated onto a sort of spun bond material. So yeah, that's interesting. It is basically just a stack of dry batteries. That is, when you add the water, it reconstitutes it. But ultimately, at that point, you've activated the batteries, and they're just going to now discharge chemically as an ordinary battery would. So that after the 72 hours of light, which it probably will diminish in that time, when you add further water, it just won't work anymore after that, which is a shame because a water-powered battery would be great. But yeah, all very interesting. You know, it's quite good to see what's inside one of those. Just basically a stack of flat batteries. Okay, a quick revisit to the my DIY one with the coins. I've increased it up to 6 and watch what happens. This is why it wasn't working. See when I dip it in the vinegar, it was basically just shorting out through the vinegar as this, you know, as the cardboard, the electrolytic separators went in. So yeah, that's why that wasn't working, but now it is. And it's lighting quite brightly, I have to say. As you can see here, it's actually a modest amount of lights coming out of it. So yes, you can make one out of cardboard. In the case of these, they're copper 2p coins and zinc-coated washers. So I'm going to leave this running. I'm just going to see how long this runs for now. I've soaked it, and if it can be reanimated with water afterwards. Yeah, well, I'm glad that kind of worked out, and I'm not so glad that it didn't really go as well, you know, during the video, but not to worry. It happened, and well, here we have it. Your very own Blackout Buddy made of stuff that you've got round the house. Just the coins, the copper discs. You can also use aluminium foil for as one of the metals. You know, just it's worth experimenting with metals, but the further they are away from each other in the chart of sort of like the electron, is it electron volts? I'm not sure. Each metal has a sort of voltage. It's in a scale, and you know, some will be positive with reference to each other, and others will be negative. But if you get them, the further away they are, well, ultimately the more reactive they are, but the less you're going to need to actually make an LED light. But the LED is lighting. That's a good result. And for the finale, I stuck all the bits together again. You said dripping water out everywhere. wrapped it firmly in sellotape with the LEDs stuffed across it, and it works. Oh, actually one of the LEDs gone out, but that's a minor technicality. My other one, on the other hand, though, is just, yeah, it's just gone dim. You know, so quickly, there must be a lot of, you know, it must be the chemical reaction between the metal surfaces. Oh no, now it's gone bright because I've just squeezed it. Ugh, blimmin' heck. It's just weird. I think this is a fairly close friction fit in this case, because I noticed if you squeeze it, and this kind of goes to, this is reminiscent of what I guess was a April Fool joke on EEV blog about squeezing extra juice out of batteries. With this one, if you squeeze it, it actually works, you get more out of it. But yeah, so it's an interesting device. It was quite fun to take apart, and now we all know a bit more about batteries.